Hey everybody, today we're going to take a look at what happens when we are trying to solve an equation for a variable, but we've got variables on both sides of the equations. Now you've probably heard me or Mr. Rake say that an equation is like a balance or a scale. So today we're going to use this manipulative at Polypad to show us how a scale can help us figure out what those values of x are. So here you can see I have got negative 3 plus 5x equals 4x minus 10 at the top of my page. I have got 1, 2, 3 negative 1 tiles and 1, 2, 3, 4, 5 x tiles on the left side to match the left side of the equation. And I've got 1, 2, 3, 4 x's and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative 1 tiles to match the right-hand side of my equation. Now, what is important to note is once you get your equation set up, if you're using this manipulative, once you set it up to match the equation, you have to tap the center of your balance and it will give you the option to balance it. It's not giving me the option right now because I already did it once. So when we have a scale, it is important that we keep it balanced. I want to see what 1x is equal to, so let's start moving all of my x's to one side of the equation. If I take an x off here, it's going to unbalance my scale. So I can take an x off here and rebalance it. I can keep going back and forth, taking x's off of both sides until I'm left with only variables on one side of the balance and it is balanced. Essentially what I did was I took 4x off of this side and I took 4x off of this side. Those canceled and made 0. So that got me 3 plus 1x equals negative 10. Now my next job is to get rid of my constant, my negative 3. Well, what is the opposite of negative 3? Positive 3. So I'm going to add 3 onto my scale, and as you can see, it made it go off balance. Whatever I do to the left side of my scale, I have to do to the right side of my scale, and I'm going to line those up. So what I just did, see it rebalanced, is I added 3 here, those cancel, and I added 3 here. That gets me negative 7. On my scale, it doesn't quite look like that because I've got a bunch of 0 pairs. If I have a 1 and a negative 1, those cancel each other out and make 0. You can see I can remove those and it doesn't change my scale at all. So I can remove all of those 0 pairs and it does nothing. Now I've got that 1x I was talking about, and I can get rid of these 0 pairs and my scale will stay balanced. It's not doing anything to my scale because I'm just removing zeros. Now you can see that I've got 1, 2, 3, 4, 5, 6, 7. My 1x is equal to negative 7. We're going to do a couple more problems like this, and then I will give you guys time to practice. Okay, here we have the equation negative 2x equals x minus 7 minus 8. And you can see that my scale isn't balanced yet. I wanted you to see that you click this center part and click balance, and now my scale will balance out. So I've got my equation, I've balanced my scale. Again, my goal is to get all of the x's to one side and all of the constants to the other. So I've got this x over here, and I want to get rid of it. The opposite of a positive 1x would be a negative 1x. So I could put that here, but that's going to unbalance my scale. Since I did it to the right side of the scale, I need to do it to the left side of the scale. Now I'm balanced again. Algebraically, that just means I subtracted x. This becomes negative 3x, and this becomes negative 7 minus 8. I could go ahead and remove these two if I wanted to because they just make 0. Now, together here, I can see I've got a negative 7 here, and I've got a negative 8 here. I could combine those like terms and say, well, what is negative 7 minus 8? That's going to get me negative 15. So I could just rewrite this and call it what it is, negative 15. So now I know that negative 3x is equal to negative 15. I want to find out what 1x is equal to. So I've got 3 groups here. I'm going to turn those on their sides so it's a little easier to see. And I've got a whole bunch of 1s over here. I'm going to group these out into 3 equal groups so we can kind of see what we're working with. Let me just get rid of all of these for a second. So I'm just going to make equal groups of 3. I'm sorry, 3 equal groups. And I can see that in each group I've got 5. So negative x is equal to negative 5. That should make sense to us because 15 divided by 3 is 5. But I don't want to know what negative x is equal to. I want to know what positive x is equal to. We know that in the algebra world, a negative divided by a negative is, of course, a positive. So what happens when I negate this? It changes stuff, right? So let's take the x that I just flipped to positive, and let's take all the constants that went with it and flip those to positive. We're back at a balance. I could flip all of those, make them all positive again. We're back at a balance. Take all those, make them positive. We're back at a balance. So now I can see I've got 3 x's, I've got 15, they're balanced. I can get rid of all of those and keep my balance. I can get rid of all of those and keep my balance. I'm down to just 1x and 5. So x has to be equal to 5 based on my original equation. If I wasn't sure, I could always go back and do negative 2 times 5 equals 5 minus 7 minus 8 and do that and solve it. We will do one more together and then I will let you guys go ahead and practice. All right, here we have 6 times the quantity of x plus 1 equals 8x minus 6. And again, I haven't balanced it yet because I wanted you to see. I have to click on my balance and click balance. So when you're using this tool, make sure you balance it before you start working. So when I've got 6 times x plus 1, that really means 6 groups of x plus 1. So you can see I've got 1, 2, 3, 4, 5, 6 groups of x plus 1. Could I rearrange that? Yes, I know I've got 6 x's and 6 constants of 1, so I could call it 6x plus 6. That's the same thing you get if you distribute. Over here, I've got 8 x's and negative 6. So my goal, again, is to get all of my variables to one side and all of my constants to the other. So I could take a variable away from this side, but that unbalances me, so I have to do it from this side. I could take one from this side, but I got to take one from that side. And I can keep going back and forth until I get rid of all the variables on one side. If I were solving this algebraically, that would look like first distributing 6 to x and 6 to 1, and then I would subtract 6x, subtract 6x. I'm clearly left with just 6 on this side, and then I've got 2x minus 6 on this side. So I can see that 6 is equal to 2x minus 6. My next goal is to get rid of these negative 6. So I know that if I add 6 to negative 6, it will cancel out and get me 0. So I'm going to add 6 to this side. And then I'm out of balance again. You can see my pan has tilted, so I got to add 6 to the other side as well. Oops, didn't mean to do that. So you can see I'm back at balance. And algebraically, what that looks like is adding 6 to get 2x and adding 6 to get 12. I can get rid of a negative 1 and a 1 because they make 0. I can get rid of a negative 1 and a 1. So I can get rid of all my 0 pairs, and I still stay balanced. So now I know that 2x's are equal to 12. I'm going to erase some of this to give me space to write. Okay, now I need to split them up. Most of you are probably thinking, hey, Corby, this is a one-step equation. I can just split them. Yes, you can. So I'm going to divide all my x's into 2 equal groups. So when you do that, you can see, oh, hey, 1x must be equal to 6. Algebraically, that looks like this. 12 divided by 2 is 6. 2 divided by 2 is 1. That gets me 1x. I can get rid of all of this because I'm taking an x from the right side, which has to be equal to 6, and 6 from the left side, and it will keep my scale in balance. So, major takeaway from this. It is just like solving two-step equations. If you have any distributive property, you should distribute. If you have any like terms to combine, you should combine like terms. Then you're just going to subtract an x from either side, or whatever your variable is, until you get all the variables on one side, and then it's just like a one or a two-step equation, just like we've been doing.